highlighters. This can get confusing if you don't pay attention. If you pay attention, I'm quite certain that by next week, Monday, Tuesday, we've got this down, okay? So the ambiguous case of the sine law. This is only an issue, okay? I need to repeat this because sometimes students think, oh my goodness, is this always going to be a problem right now? This is only an issue when you have SSA cases. Let me give you a quick way to figure out whether or not this triangle is an SSA. So let's say you have angle A is 40, side A is 5 centimeters, side B is 8 centimeters. Is this an SSA? Yes, because in particular, you're going to realize that we have a pair plus one side. That's how you know you have an SSA case. Highlight that part. If you have a pair, a known pair, and another side, we are in SSA territory, side-side angle. You don't need to worry about the SSA too much, just the fact that, okay, this is going to be the ambiguous case, okay? As mentioned earlier in this unit, cosine of an obtuse angle results in a negative ratio, okay? So try that, cosine of 100. If you go cosine of 100, which is an obtuse angle, I'm going to clear my screen, sorry, I'm going to try this again. Cosine of 100, you get a negative, right? So negative 0.17, and that keeps going. At the same time, applying the inverse of cosine to a negative ratio will result in an obtuse angle. So cosine doesn't have a problem. It knows the difference between an acute angle and an obtuse angle. That's what I'm trying to say here. What about sine? Let's explore this. We'll omit the tangent for now because we're not using it. But let's fill this table in real quick, okay? For now, you're just going to copy. So we're going to look at the sine of different angles. So sine of 20, just write this down for now. It's 3.3420. Sine of 50 is 0.7660. Sine of 75 is 0.9659. Okay. Why did you pick these angles, Mr. Dixon? Is there a particular reason you picked these angles? No. But what do you notice about all of these angles? They are all acute, right? All of these angles are acute. We got these results when we entered it. Let's try the same with cosine. Just write this down for now. 0.9397. Cosine of 50 degrees would be 0.6428. I'm rounding to 4 decimals. Cosine of 75 is 0.2588. Okay, now this is where I want you to focus a bit more. This is theta, that's just a letter for angle, right, a Greek letter. What if we go 180 minus theta? What does that mean? These two, if they add up to 180, these would be supplementary to each other, right? So if theta is 20, what's 180 minus 20? 160. If theta is 50, what's 180 minus theta? That'd be 130. If theta is 75, if you take that away from 180, we've got 105, okay? Write down all of these are obtuse. Okay. So let's find sine of 160. This is where you can grab your calculator if you are wanting to follow along. Sine of 160. What do you get? 0.3420. You see that? What did we get earlier? Sine of 20. Aren't they exactly the same? See that? They're exactly the same. Sine of 130, let's do that again. So sine of, this is, I know this is confusing the way it's notated, but I'm just telling you that we're taking the sine of the supplement of 20, right? Now we're taking sine of the supplement of 50, which is 130. So let's go sine of 130 is 0.7660. What do you notice about the one for sine of 50? They're exactly the same, correct? You don't seem impressed yet. What can we deduct is going to be the ratio here for sine of 105? It's going to be exactly the same as this. Okay, so we'll make a note of that. Exactly the same. Exactly the same. Nothing changed. What about cosine of 160? Do you think cosine of 160 is going to be the same as this? To a certain degree it will be, but there will be a difference there. Let's go cosine of 160. We get negative 0.9397. Okay. What is the difference between cosine of 20 and cosine of the supplement of 20? What's the difference? The value is the same, but we have a negative here. Okay. What do you think is going to be the case for all the other ones? If we know that cosine of 50 is this, cosine of the supplement is going to be negative 0.6428. Cosine of 105, which is the supplement of 75, is going to be negative 0.2588. So that is the point I'm trying to make. Sine law, sine doesn't know the difference between acute or obtuse. Cosine does. It uses the sign for it, okay? All right, keep going. All three trig functions return a positive. Guys, let's follow along for now, okay? All three trig functions have the same numeric value for an angle and its supplement. Okay. Only cosine and tangent return a negative value for obtuse angles. And you're like, where did tangent come from? Don't worry about it too much. Like, we're just focusing right now on cosine. Cosine, as opposed to sine law, gives you a negative for an obtuse. Sine will give the exact same value, and sine. So this is important to highlight. Okay? Sine does not distinguish between acute and obtuse and will always return an acute angle. That is a problem for us. Okay? I'm going to move along after this. Okay, I'm not going to do the rest. So here we go. I want you to go to page, yeah, let's go 96, bottom of 96. State if the following are true or false. Okay? Is cosine of 7 going to be exactly the same as cosine of 173? You got to watch out. Let's try that first without, I'm not going to go into the shortcut just yet. Cosine of 7 is 0.9925. Is that going to be the same thing as cosine of 173? What do you have there? Negative 0.9925. So watch this. You've got to cross this out. They're not going to be the same. Okay? So basically what you should have noticed is, wait a minute, these two are what? What are these two angles? They're supplementary to each other, right? They equal to 180. So there's something we know. We know that the numeric value will be the same, exactly the same, but the sign will be different. But still, you can't have an equal sign there. They're not the same. So when you come across these questions, just use your calculator and that's it. Okay, you're good to go. Is sine of 56 going to be the same as sine of 34? Are these supplementary at all? No, so they're like, it's not even a question. They're not going to be the same. Okay, so sine of 56 is 0.829 and sine of 34 is 0.559. It's not even, they're not even the same numerically speaking. Okay, they're not even the same. Question here, without a calculator, what do we know about this? Is the left side going to be equal to the right side? Do these add up to 180? Not equal to 180, right? So they're not going to be the same. This adds up to 200 degrees. It's not even the same. But if you notice that these are supplementary and they're both sine, you know they're going to be the same. And if you, worst case scenario, use your calculator, right? You just go, this is 0.985, rounded to 3. Sine of 120 is 0.866. If you do 3 decimals, that's fine. So you still can't say that they're going to be the same. What about this last one? Is this going to be true? Let's try it. Cosine of 120 is what? What sign is it going to have before I hit equal? It's negative, right? Negative 0.5. And that's supposed to be equal to negative, watch this. What's cosine of 60? 0.5. But wait a minute. Isn't this the same? It is the same. So in that case, this is true. Okay? This is true. All right. Let's keep going. Let's go to 97. We're going to predict the value of supplementary angles. Okay? What I mean here is without a calculator. Make sure you write this down, though, without a calculator. I will, if I tell you to predict without a calculator, I'm telling you, don't use a calculator because you're going to get it wrong, okay? So basically what I'm saying is this. Start with the sine of 73. That part you can do. 0.956. 0.956. If you want 4 decimals, that's fine with me. If you want 2 decimals, that's also okay with me. What will be sine of the supplement? This is the supplement. What is the supplement of 73? 107, right? Right? These are supplements. Okay? If sine of 73 is 0.956, what's sine of 107 going to be? Based on what we started with. It's going to be exactly the same. Okay? If cosine of 118 is 0.123, I'm just making this up. I'm just making this up. This is actually not true, right? Sorry, it's negative because it's going to be, this is obtuse, right? What's the supplement of 118? Sorry. 2 gets me to 20, so 62. If I told you that cosine of 118 is negative 0.123, what do we know about cosine of the supplement? It's going to be the exact same number, right? But it's going to have a positive, so I'm going to make sure that that is there. I will make a note here. Values are not based on calculator. I can tell you that it's not negative 1.23, okay? I just made it up so that you see the pattern, okay? I don't want you to worry about tangent. That's all I'm going to do there for now. I think I'm going to stop here because I will need more time to do the actual deep dive lesson on this, okay? I just wanted you to start seeing why is sine law, why is it a problem? Because sine law doesn't distinguish between acute and obtuse. That's basically all that I wanted to do right now, okay? Then we're going to take it a step further. I'm going to do page 100 before we go. That one I can do, but not the deep dive, okay? The deep dive we'll do on Monday. It's not 1, 2, 3. Is that what you're wondering? I made it up, okay? Okay, this is very important. I'm going to tell you not to use your calculator in these instances. The question will say it. So if I say cosine of 118 is negative blah, right? You need to be able to tell me that cosine of the supplement of 118 is positive of whatever this was. Right? So that's all I want you to see, that pattern. I did not use a calculator for this one. Okay? And the reason I will do that is just to test, do you understand the concept? Okay? So please don't think that it's actually 0.123. It's not true. Okay? Way to confuse us, Mr. Dirksen. Like, why would you do that, right? You know. I'm weird sometimes, okay? You're like most of the time. Anyways, let's do this one real quick. I have a roof here, and I want to find that roof cap. I want to find that angle at the cap of the roof. Let's call that R. What law would I use to do that in this case? Side, side, side. I would use cosine law. Thank you. So cosine of R. Make sure you write this down, and then you can talk about the weekend. 17 squared plus 20.3 squared minus 33.5 squared. 2 times 17 times 20.3. what do you get at the top? Let's do that top part real quick. I'm just trying to find my answer here. Today is not a good day for answers, as you can tell. Okay, so here we go. Negative 421.16. Then it's 2 times 17 is 34 times 20.3. That's 690.2. If you divide these two numbers, you get negative 0.6101 something. Let's see if you're awake. Angle R is going to be a what kind of angle? Obtuse. How do we know? It's negative. There we go. Thank you. So we're going to go cosine of negative. Tell Mr. Dirksen what he wants to hear, right? Cosine of that, it's 127.60 degrees. No problem. Cosine, we know cosine can handle it, right? But what if I put a twist on this question and I give you different information? Not side, 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 but this scenario. It's the exact same roof, guys. It's the exact same roof. What do I need to do here in order to solve for the cap up here? I have a pair, right? I have to use sine law, and then this side will allow me to solve for that one. Let's do that. Sine of 28.69 over 20.3. Sine of R for the top over 33.5. Sine of R is found by cross multiplying and dividing. If you do that, use your calculator. .7922 something. 0.7922 dot dot dot. Angle R. Let's take the inverse. Drum roll. Is it going to be obtuse? Is it going to be obtuse, you think? Because sine law is kind of dumb, right? Sine law doesn't know. Poor sine law, right? 52.39. What's up with that? We know it's 127.9. Right? We know that. So let's do that. R is 52.39 something. But this can't be, since angle R is obtuse. So here is what sine law does. Okay, let's draw our triangle. We know it technically looks, I'll draw it like the roof, so you're not confused by this. I'm turning it technically. But we know that this is technically 127.6. Okay, guys? You know what sine law did? You know which angle it found? It gave you this one, 52.39. That's not the one we want though, right? But sine law, it will never give you an obtuse angle. It will just never. So what could we do to find the one we actually want? What could we do with this? We just go angle R is, what do these two add up to? 180. Right now it's scary, guys. I will show you how to make sure you get this right every time, okay? I'm just showing you the problem with sine law. So go 180 minus that angle, you get 127.61. Ooh, it's a little bit of a rounding error, right? But that's okay. And that's the angle you actually wanted, but sine law doesn't account for that. So we need to come in there and make sure we address that, okay? We got to make sure we address that. More of that next week.